Hi, welcome to video 2 of The Critical Path. I'm Callum, the lead trainer for Training Bite Size, and in the previous video we looked at the network and how we created this diagram, the finish to start relationship, the arrow showing that I have to finish A before I do B, C and E, and I have to finish before doing B and C before I do D, so on and so forth. And that shows me this logical flow. I've always liked doing it visually like that. In fact, I used to use post-its, and I used to have these magnetic laminated things I used to pin onto walls and things to help me build schedules. I've always found it very helpful. I mean, a lot of people just go straight to the Gantt chart. That's what the software does. But I do think workshopping the logic can be very helpful sometimes, and sitting down with your teams or groups of people and just working out what the logical order of tasks is, and then visualizing using this. We also went through in the previous video what was on these boxes, these nodes, what they're called. So you have your earliest start, duration, earliest finish across the top. Task name and ID is in the middle. That's from our work breakdown structure. Latest start, total float, and latest finish along the bottom. We'll worry about what total float is in a minute. Okay, ignore it for the time being. We'll come back to that in a minute. Want to just start off with the duration, which is in the top middle. So we'll need to do some estimating to determine how long each of these tasks is. Estimates come from a variety of different things, but effectively all an estimate is looking at previous knowledge, previous data, whatever, to predict the future. It is an element of guesswork. We can build that guesswork into our estimate if we want to, doing things like PERT analysis and weighted averages, things like that. We can build contingency into our estimates. I'm not going to worry about any of that today, purely looking at the maths. So I've gone through my estimating with my stakeholders, with my team, etc., and we've determined how long each of these tasks is going to take. So with my team, with my contacts and everything else, with my experts, etc., I've determined that task A has a duration of 1 day. I've also determined that task B has a duration of 2 days. Task C has a duration of 4 days. Task E has a duration of 6 days. D, let's say, has a duration of 3 days, F has a duration of 4 days, and G has a duration of 3 days. So there's my durations. We've done our estimated, we've now populated this diagram. So this is the critical path bit, this is the maths now, okay? So with this task, with this network, we have an order. So we're starting on the left. So typically on a Gantt chart we work left to right. With this we work left to right. So the first task in the whole project is going to be task A. Based on the logic, based on what we talked about in the last video, task A is the first task in the whole sequence. So we're not worried about dates, we're not worried about what date the start of the project is, what date we need to finish in. We're not worried about any of that. This is purely mathematical. So in maths, the earliest we can start counting from, technically, is 0. So the earliest start for task A is going to be 0. Now there are views of it starting on different days. So for example, I know a lot of people in the US will use day 1 as the starting date, or starting the mathematics start anyway. But for this, we'll keep it nice and simple. We'll say day 0. So i.e. we're starting at the earliest possible point, so 0 of the first day. So we put 0 in there, day 0. My argument for starting on day 0 rather than day 1 is because we have a whole year of being alive before we're a year old. You know, until we are a year old, we are 0 years old. So that's the case here. So we are starting on day 0 because nothing's happened yet. Task A has a duration of 1 day, and I'm using days here. It could be anything else, but we typically use days. So task A has a duration of 1 day. So what we're going to do is add the duration onto the earliest start. So 0 plus 1, and that will tell me my earliest finish. So 0 plus 1 tells me my earliest finish is 1. So that tells me that at some point on day 1, task A is going to finish. Now it doesn't tell me when on day 1. It doesn't tell me we're finishing at 5 o'clock in the evening or midnight or whatever. It just says at some point on day 1, task A will finish. So task B cannot begin until A is finished, and A is finishing at some point on day 1, which means in theory, if we're not talking about any sleep or rests or anything else like that, I'm not worried about people finishing at 5 o'clock in the evening or whatever, we'll assume that everything can start the moment one task finishes. So if task A finishes at some point on day 1, then in theory B could start at some point on day 1. The moment A finishes, B can start. So the earliest start for B will be 1, because it can start the moment A is finished. Which means C, which is also dependent on A, could start on day 1. And E could start on day 1. So again, I'm not saying when on day 1, it's just saying the moment A finishes on day 1, in theory, if we're not having any sleeps or rests, B, C, and E could begin immediately. Again, this is mathematical, this isn't reality. There's no dates, there's no resources or anything like that yet. This is purely mathematical. So if I had the durations on then, so the duration of B is 2 days, so 1 plus 2 is 3. So my earliest finish for B is day 3. C, 1 plus 4 is 5, so my earliest finish for day C, for task C, sorry, is day 5. And then E, 1 plus 6 is 7, which means the earliest finish for E is day 7. Now E finishes on day 7, sorry. D cannot start until both B and C are finished. So B finishes at some point on day 3, C finishes at some point on day 5, which means I cannot begin D until both tasks are finished and C finishes last. So when the easiest way to remember this, when you're going down left to right, when you're going, this is called the forwards pass we're doing, by the way. When we're going left to right, when you have a choice between 2 numbers or maybe more to put into a following node, so D has 2 tasks going into it, so B and C going into D, carry the highest number forward. So B is finishing on day 3, C finishes on day 5, which means D has to wait until day 5 to start. F has nothing to do with B and C. It's only dependent on E. If you look again, there's the arrow there. There's no other arrows going into F, which means as long as E is finished, F can start. And E finishes on day 7, so we carry the 7 down the arrow there, and F can start on day 7. So the duration of D is 3, so the earliest finish is going to be 8. The duration of F is 4. Earliest start is 7. 7 plus 4 is 11. So again, same principle. So when we have a choice, we've got D finishing on day 8, F finishing on day 11. We have a choice, therefore we carry the highest number down the arrow. Earliest start for G is day 11. Duration of G is 3. 11 plus 3 is 14. So that tells me the duration of the whole project now. This project is 14 days long. Again, we're not worrying about time off or weekends or anything like that right now. This is purely, again, mathematical, raw look at the schedule. This project is going to take me 14 days. So the next thing is to work out, or to do the backwards pass, where we're going to go right to left. So what we're going to do here, the reason we're starting on the right-hand side is because, if you remember, the bottom right is the latest finish, i.e. that's the latest that task can finish and still deliver the project on time. Well, we've determined how long the project is. It's 14 days. So I don't want the project to take longer than that. I mean, you could arbitrarily make it longer. You could say we've got 20 days or whatever, but that's not what we're doing here. This is a mathematical look at the project. I've determined that the duration of this project is 14 days. Therefore, the latest I'd like it to finish is also 14 days. So to get the latest finish for the end of the project, so again, you're working right to left this time, starting on the bottom right, I carry the latest, or the latest finish is gathered or gotten from the earliest finish. So project finishes on day 14, therefore the latest I'd like it to finish is day 14. I don't want it to take longer than that. So we're kind of doing everything the opposite way around. So forwards pass, we're going left to right, and when we have a choice, we carry the highest number down the arrows. On the backwards pass, when we're going right to left, we're going to carry the lowest number down the arrows. And I'll show you what I mean by that in a second. But for now, on the forwards pass, we added the duration on to get the earliest finish. Here we're going to subtract the duration to get the latest start. So 14 minus 3. So let me just illustrate that for you. That minus that equals that. Okay? So 14 minus 3 will tell me the latest start for task G. So 14 minus 3 is 11. So that tells me that G cannot start any later than day 11 and still deliver the project on time. So that then carries back down the arrow then. So for example, D is going into G. So that tells me if the latest start for G is 11, then that's the latest I can finish G and still deliver the project on time. So I'm carrying the 11 back down the arrow. So again, just to show you, that number gets carried back into that number there, or into that box there. And the same with F. So latest start for G is 11, therefore the latest finish of F will be day 11, which means D and F cannot finish any later than day 11 and still deliver the project on time. If they're later than that, the project will be pushed back. So going back to D, subtract the duration, 11 minus 3 gives me 8. That tells me that D cannot start any later than day 8 and still deliver the project on time. Going F, 11 minus 4 gives me 7. Notice I'm trying to do it in columns. I think it makes sense to do it in columns, bit by bit. It kind of helps it be a bit more methodical if you're having to do this by hand for whatever reason. So again, the latest start for D is day 8, therefore D cannot start any later than day 8 and still deliver on time, which means B cannot finish any later than day 8 and still deliver the project on time. So the 8 carries from that back down the arrow to go in there. That is also the same for C, because D cannot begin until C is finished, and so C has got that dependency with D. The latest start for D is 8, therefore the latest finish for C is day 8. F has nothing to do with B, C or D, so we're only looking at that latest start of 7 there. Just carrying that back down the arrow, that's the latest finish for E. So doing the same thing again. So for B, 8 subtract 2 gives me the latest start for B of day 6. For C, 8 minus 4 gives me a latest start of 4. And E, 7 minus 6 gives me a latest start of 1. So that tells me that B can start no later than day 6 and still deliver the project on time. If C starts any later than day 4, the project will be delayed. And if E starts any later than day 1, then the project will be delayed. Now, I mentioned a minute ago that with the backwards pass, which is what we're doing, going right to left, going across the bottom of the boxes, we take the lowest number. So basically what I mean by that is, if A is going into B, C and E, because of E's latest start being 1, if E starts any later than day 1, the whole project will push back. Which means if A finishes any later than day 1, then it will affect the start of E. And if it affects the start of E, then it will affect the whole project. So when you're going back down the arrow, when you have a choice, so we have 3 choices here, we've got 6, 4 and 1, we carry the lowest number down the arrow. So the latest that A can finish is day 1. And you know you've got the critical path analysis, the maths part of it anyway, right, is when you do the last, or the first task, technically I suppose, the last part of this backwards pass, where you get back to the original task, so task A in this case, 1, latest finish is 1, duration is 1, 1 minus 1 is 0. So you should get back to the first task in the sequence and have both of these numbers be 0. If they're not, something's gone wrong with your math somewhere. Or you've skewed it. You've arbitrarily inflated something somewhere, which you shouldn't do, I'd argue, with this. This is about determining the critical path, not efficiencies and stuff like that. It's about where is the critical path and trying to highlight it. So I've got back to 0, which means I've got things right. Now the last bit is to do this total float bit. What that total float is, we'll talk about in a sec. But for now, let's tell you how to do the math. So I want to compare this number and this number. So I want to compare the latest start with the earliest start. So we're looking for the difference. So the latest finish, subtract the earliest finish. So 0 minus 0 tells me that the total float for task A is going to be 0. So this minus this equals that. All right. You can do it another way. You could do the finishes. So you could do that minus that equals the float as well. Because if you do 1 minus 1, so latest finish is 1, earliest finish is 1, 1 minus 1 equals 0. 0 minus 0 is 0. So either way you do it, you'll get the same, or you should get the same result. You can do. I used to do it as another sort of idiot check, I suppose, for myself, just to make sure my maths was sound. So if we do the same thing for task B up here, 6 minus 1 equals 5. If I do it a different way, so compare the finishes, 8 minus 3 equals, well, 5. So yeah, you can. It shows that your maths is, or shows that maths is right. So the total float for task B is 5 days. 6 minus 1 is 5. Same for C. So 4 minus 1 tells me we've got a total float of 3 days. Whereas E, 1 minus 1 is 0. D, 8 minus 5 gives me 3. F, 7 minus 7 gives me 0. Just tidy it up a little bit. There we go. And then for G, 11 minus 11 gives me 0. Now hopefully you're able to start seeing where this critical path is. So total float is the amount of wiggle room a task has before it affects the end date. So for example, if any tasks on the critical path, so A, E, F and G are on the critical path. So these tasks here, A, E, F, G. because they have 0 total float, which means if any of those tasks are late, the whole project will be pushed back. So if A is late by a day, then the project takes 15 days rather than 14. However, tasks with total float in, so B, for example, has 5 days total float in it in the bottom middle. That's telling me that B could be late by up to 5 days and still deliver the project within 14 days. C could be delayed by up to 3 days or extended by 3 days and still deliver the project within 14. D could be delayed by up to 3 days or extended by 3 days and we'd still deliver the project within 14 days. So total float is the amount of wiggle room a task has on it before it affects the end date. The critical path is the tasks with 0 total float, or the least total float technically, which is 0 in my case, in this project's case. It should be if you've done it properly, incidentally. And that tells me those tasks are the ones with the greatest risk to the timeline. If any of those tasks are late, the project will be late. So that's showing me where the tasks with risk, or the greatest risk is, if we're talking about timeline risk anyway. A couple of other definitions to kind of keep in mind with critical path is it's the longest path through the project. And what I mean by that is if you add up the durations of the critical path, so the duration of A is 1, duration of E is 6, duration of F is 4, duration of G is 3, if you add those up, it tells you 14 days. The result is 14. So the reason my project is 14 days long is because of the critical path. So if my stakeholders come to me and say I want it done quicker than that, I cannot do it quicker than that because A has to be done before E has to be done before F has to be done before G, and I might have got those estimates wrong, but according to my estimates, I can't do this any quicker than 14 days. So if my stakeholders want it in 10, I literally can't do it quicker than this. Because that's the critical path. The critical path tells me that it's a 14-day long project, therefore that's what it's going to have to be. So it gives me some information that I can now use as sort of as evidence for communication. Gantt charts can show this too. They should show this, arguably, but because Gantt charts, the technical word is fudged, get fudged quite a lot, and people don't think about this network, don't think about the precedence, don't think about the relationship between tasks, you end up with all these kind of wacky schedules that don't mean anything. For example, every task has to have an arrow going into and out of it, apart from the first and last task. You can't have tasks just floating around in the middle of nowhere with nothing going into or out of them because it makes no logical sense. If I just drawn up here, if we've got another task, a task H whatever, just floating up here somewhere, and there's no tasks going into or out of it, then what has to happen first then? Or where does H sit in the grand scheme of the project? It can't just float in the middle of nowhere. It has to have some dependency. Either it starts the project, it's somewhere between A and G, or it comes, at the end of the project. So it has to make sense. You can't have these floating tasks. But Gantt charts, because people fudge them together and just make stuff up a lot of the time with them, they don't factor those dependencies in. And this network does help with that sequential logic. And then the critical path gives you some evidence to show what that logic, the consequences of that logic will be for the project's timeline. This will convert into a Gantt chart. It's very easy to turn this into a Gantt chart, especially with Microsoft Project, which has done all this before you. Incidentally, if you press a button saying network in Microsoft Project, you'll see this sitting in the background. Looks slightly different to how I've drawn it, but it's essentially showing the same information. That shows the critical path. That's how you do the maths. There's one last bit of maths I want to show you, which is called free float. So total float is the amount of wiggle room a task has on it. So B has 5 days, C has 3 days, D has 3 days wiggle room. In green, the green numbers in the bottom middles, that's my total float. The other type of float is free float, and that is how much wiggle room a task has before it affects the start of the next task. So, for example, I don't want to confuse too much with this one. If B does take 5 days longer, so it does, it get extended by 5 days, it's due to finish on day 3, task B. But if it gets extended or delayed by 5 days, it will finish on day 8 instead. And if B finishes on day 8 instead, then it will also mean that D starts on day 8. And if D starts on day 8, it will no longer have any total float in it. Because if D starts on day 8, last 3 days, then it will finish on day 11, which is the latest finish. So there's no total float left. Free float, though, is how much wiggle room I have before I affect the start of the next task. So if we look back at D again, D starts on day 5. And that's because C starts on day 5. Finishes on day 5, sorry. B, however, is expected to finish on day 3. which means provided B finishes before day 5, nothing will change. So what I'm looking at here to determine my free float, oops, I'm looking at, get this right eventually, this number and this number. Is there a difference between them? And the way to look for free float is where there's more than one arrow going into a task, you can spot free float, but there might be an opportunity for it. So for example, B finishes on day 3, D doesn't start until day 5, which means provided B does not go over 2 days late, it has 2 days free float. So if B was 2 days late, it would finish on day 5. And D isn't due to start until day 5, so there'd be no change to my schedule at all. So hence why it's called free float. There's no consequences to your schedule. There's consequences elsewhere, you know, like resource costs and stuff. But in terms of scheduling, provided B doesn't take longer than 2 days extra, so it's not extended by longer than 2 days or delayed by 2 days, and D still starts on day 5, then nothing on my schedule will change. That's called free float. I wouldn't worry too much about that one, especially if you're looking at doing PMQ and stuff, because they don't tend to really ask you about it. But it is another type of float. All right, but that is the maths. That's how you do critical path. Hopefully that was useful. Yeah, thank you very much, and hopefully you got something out of that. And I'll see you again another time. Cheers, everyone.